This meeting is being recorded.
Okay, hello everyone. Today we will discuss combined series parallel circuit. We can see in the figure 1 the original circuit, which is simulate. The circuit is with 12 volt and with 0.277 ampere. And also for each resistor, there's it's showing its voltage and its ampere, its current. So we can see in the resistor 1, 10 ohm with the 2.77 volt and 0.77 current. Because it's in series, the current will be same as the original current and the voltage will be different. And the resistor 220 ohm, it's in parallel with 40 ohm. So the voltage will be same, but the current will be different. So we can see its current is 0.185 ampere, but in the 40 ohm, we can see the current is 0.0923 ampere. So that's, and in resistor 4, it has a 5 ohm. The voltage will be different because it's in series. So the voltage will be 1.38 volt, and the current will be same as the original because it's in series. So the current is 0.277 ampere. And for the resistor 5, it has a 5 ohm and voltage is 4.15 volt. The current is 0.277. So we can move to the figure 3. The figure 3 showing the required, we have to disconnect each resistor one by one. So the first one we will disconnect resistor 1. When we disconnect resistor 1, we will get all in voltage and current. It will be 0. So we will get this result. But when we disconnect 20 ohm, we can have in 10 ohm, we will get a voltage 1.71 volt, and the current will be same for all resistor because now it's in series because we disconnect one parallel, so all in series. The voltage is different, but the current is same. And we would when we disconnect 40 ohm, also we will get. Can you move, Ryan? When we disconnect 40 ohm, also will be the same as the previous one because we disconnect one parallel. So the voltage will be different because now all resistor in series and the current will be same. And we can say for 10 ohm, the voltage is 2.4 volt and the current 0.240 ampere. Also, as well as the 20 ohm, the voltage 4.8 volt and the current 0.24 ampere. And 5 ohm will be 1.2 volt and the current will be 0.240. Also as 15 ohm. So when we disconnect 5 ohm, we will get the result same as the previous result we get when we disconnect 10 ohms. So all resistor will be 0 volt and zero current. And for the last one, 15 ohms, also we will get same result as the 5 when we disconnect 5 ohms and 10 ohms, because we disconnect one resistor in series. So the voltage will be 0 and current will be 0. And that's it for my part. We can move to Ryan.
So for the discussion, when a resistor is disconnected or open circuit, it means that the current path through that branch is broken. So since an open circuit has infinite resistance, so no current will flow through the disconnected resistor. As a result, the voltage across that open component becomes equal to the potential difference of the points where it was connected. And for this condition, it also changes the total resistance of the circuit. Like removing a resistor from the network increase the total resistance because there are fewer paths for current to flow. So according to Ohm's law, when the total resistance increases, the total current supplied by the source will decreases. For instance, if the 20 ohm resistor in the circuit is disconnected, the parallel path is removed, and the circuit becomes a simple series circuit of 10 ohm, 40 ohm, 5 ohm, and 15 ohm. These increase the total resistance and reduce the overall current. The voltage distribution across each remaining resistor will also change accordingly. So, but in some cases, open circuiting certain resistor can completely interrupt the circuit. For example, if the 50 ohm resistor, which is in series with the source, is open circuit, there will be no current flow through the entire circuit, and all other components will have zero current. And now is for the short circuiting each resistor one at a time and repeat step 2. So for case 1, when we short on 10 ohm, the current will not flow through the 10 ohm resistor, and it will flow through the wire that with no resistance. So for the 10 ohm resistor, there will be no voltage and no current. But for the 20 ohm resistor, we will have 4.8 voltage and 0.24 current. For resistor 40 ohm, there will be 4.8 voltage and 0.12 ampere. And for resistor 5, we will have 1.8 voltage and current of 0.36 ampere. And also for the resistor of 50 ohm, the voltage will be 5.4 and the current will be 0.236 ampere. And the next one is short circuiting on the 20 ohm resistor. And the circuit is look like this. So next page. The data we have is for the 20 ohm resistor, there will be no voltage and current. But for the 10 ohm resistor, there will be 4 volt and 0.4 ampere. But this one is special because for the 40 ohm resistor, there will be also no voltage and current, since the 20 ohm resistor is connected parallelly to the 40 ohm resistor. So when we short circuiting on the 20 ohm resistor, it will also like we have extra wire to short circuiting the 40 ohm resistor also. So for 20 ohm and 40 ohm resistor, there will be no voltage and no current. For the 5 ohm resistor, it will be 2 volts and 0.4 ampere, and 50 ohm resistor, it will be 6 voltage, 6 volt and 0.4 ampere. And the third case is short circuiting on 40 ohm resistor. It will be same like the short circuiting on 20 ohm resistor. So for 20 ohm and 40 ohm resistor, there will be no voltage and current. For 10 ohm resistor, it will be 4 volts and 0.4 ampere. For 5 ohm resistor, it will have 2 volts and current of 0.4 ampere. And last one is 50 ohm resistor. It will be 6 volt and 0.4 ampere. And now is short circuiting on 5 ohm resistor. And when we short circuiting on 5 ohm resistor, we get a data that is for the 10 ohm resistor, we get 3.13 voltage and 0.313 ampere. For 20 ohm resistor, we get 4.17 voltage and 0.209 ampere. And for 40 ohm resistor, the voltage will be 4.17 and the current will be 0.104. But for the 5 ohm resistor, because we short circuiting on it, so it will be no current and no voltage. And last one for the 15 ohm resistor, it will be 4.7 voltage and 0.313 current. Okay, and then last one, short circuiting on 50 ohm resistor. So for the 15 ohm resistor, there will be no current and no voltage. But for resistor 10 ohm, it will have 4.24 voltage and 0.424 current. For 20 ohm resistor, the voltage will be 5.65 and the current will be 0.282. And 40 ohm resistor, 5.65 volt and 0.141 ampere. And 5 ohm resistor, 2.12 volt and 0.424 ampere. Now is the turn for Dimas.
Damas, open your mic.
Okay.
This meeting is being recorded.
Okay, my name is Dimas, and here I'm gonna present you about the discussion for short on. First, placing a wire across its resistor will create an alternative path for current. Current prefers to flow through low resistance compared to higher one. Hence, instead of flowing through the resistor, current flows through the wire since it has almost zero resistance. It means the resistor will choose the new cable, then then it flow the resistor because the current will choose the lower resistance. And then the second situation also change the total resistance of the circuit. Take a look at the example one, where the 10 ohms resistor is short circuit. The equivalent resistor has changed from 43.33 ohm to 33.33 ohm, according to Ohm law, where V equal to IR. Decreasing in total resistance result in an increase of total current when the voltage is constant. It means like when you make a short on the 10 ohm resistor, the current the resistor in 10 ohm will be ignored. So there is no 10 ohm resistor in the circuit. And then the last, for some case, short circuiting resistor result in short circuiting the whole circuit. For example, when 20 ohm resistor is short circuit, it affects the whole circuit where the current only flow through 10 ohm resistor, 5 ohm resistor, and 15 ohm resistor. This causes the total resistance to equivalent to 30 ohm. We can see the short on in 20 ohm and 40 ohm. If we short on the 20 ohm or 40 ohm, the parallel resistor, all of them will be ignored. So the circuit will be series, like for the short on 40 ohm and the 20 ohm. And then next, this one is the calculation for the normal circuit before short on and remove the resistor. We can see the resistor total is 43.33 ohm, and then we use the ohm law to find the current, and we found it 0.277 ampere. And then for the resistor one, the current is still 0.277 ampere, and the voltage is 2.77 volt. For the resistor 2 and the resistor 3, the the current is gonna be different because it's parallel, but the voltage it will be same. It's like 3.68 voltage. But for the resistor 4, the current is 0.277 ampere and the voltage is 1.385 volt. And for the resistor 5 is the current is 0.77 ampere and the voltage is 4.155 volt. And next, we can see like the previously, if we disconnect the 10 ohm, the current it cannot be flow, so there is no voltage and there is no current for all of the resistor. But if we disconnect the 20 ohm resistor, the circuit will be series all of them, and we can see the calculation for the resistor total, and the resistor total is 70 ohm, and the current total is 0.171 ampere. And then,
So, Damas,
sorry,
uh, we can make it quickly because the meeting will be end
okay,
in 5 minutes. So
it's okay, it's okay.
you can only say the voltage and the current and quickly, please.
Okay, it's okay.
Okay.
For if we disconnect the 40 ohm resistor, it's same with the disconnect 20 ohm. The resistor will be series all of them. And then if we disconnect the 5 ohm and the 15 ohm resistor, the circuit is there is no voltage and there is no flow because there is no cable connect with the resistor. Okay, next, this one is the calculation for the short on. For the short on resistor 10, we can see we ignore the resistor 10, and then we calculate like the normal like the normal ohm law, and then if we short circuit at 40 ohm, we can see the parallel is the is will be ignored, so there is no parallel resistor in here. Okay, next. mm, for the 5 ohm, this one is same with the 10 ohm resistor. Okay, next. mm, for the 15 is it's still same with the 10 ohm resistor because we will ignore the 15 ohm resistor. Okay, this one is also same for all of them. like a manual calculation. Okay, finish.